Voices off me.
Keep talking.
Oh my god. What does it mean?
Hey.
What does voices off mean? What does it mean? I'm waiting.
I keep my voice off.
Please answer her question.
Okay. It means stop talking.
Okay. Please stop talking.
Algebra 1, Thursday, the 7th of November, all day long, the 7th by the way, and all day long Thursday. So pretty how that works, okay? SWBA. Whitney, what's that stand for? Students will be able to. Reese, can you read what we'll be able to do?
Graph linear equations.
Graph linear equations, okay? What do you say, Kelly?
Saturday's Victoria's birthday.
Oh yeah, she's been talking about it.
Oh, today's lucky number 7, so everyone should be a lucky 7.
So, we're going to learn to graph these linear equations now. So, we solved equations with one variable, we got one solution. When we solved an equation with one variable, we got one solution. Okay, that was the thing that happened. Okay, here's an example. 3x plus 1 is equal to 10. There's one variable, and that variable is x. If we solve this, what are we going to do? Subtract 1. So 3x is equal to 9. Okay, then what do?
Divide by 3.
Divided by 3. This is light work, right? This is light work. X is equal to 3. So when we solve a variable or an equation with one variable, we have one solution. That's x equals 3. When we solve two variable equations like x and y, the solutions are sets of ordered pairs. We've seen that a little bit. Where our solutions are ordered pairs. So we'll be looking at linear equations called linear equations, and we'll learn why we call them linear equations, which are equations whose graphs form a straight line. If you look at linear, do we kind of see the word line inside of there? Yeah, you see line, AR, okay? So these form a straight line, okay? The solutions to such an equation, to the linear equations, are all the coordinates on the graph line. So we'll end up having a straight line, and every single coordinate that fits on that line is in fact a solution. We can use a table to find some of the solutions and then draw a line. So we've used tables so far. Back in 4.1, we used tables quite a bit to show our relation, okay? We're going to be looking at doing that more today, okay? As we go to the next part, I'm going to calibrate real quick though. There's a calibration game here. Oh, I have to go back. Big it. Can you put it away? Just give me Laura, can you put it away? Plug it in there, I'm sorry. Alright, so then going to the next part here, we see a graph. We see a graph here, okay? It says graph the solutions to each linear equation by making a table and graphing the coordinates. So we have this equation, y equals 3x plus 1. We also know that we call it f of x is equal to 3x plus 1, right? We learned that last class. Okay? We could call it f of x instead of y. We'll keep it as y for now. So what we're going to do is we're going to make a table. Okay? We're going to make an xy table. XY table, x on the left, y on the right. Now here's the thing though. Before when we made tables, we were given ordered pairs, weren't we? Now we have to find them. Find ordered pairs. How do we go about finding ordered pairs? Well, we take x values and we plug them in. What x values do we plug in? Well, here's the thing. We like to get a nice diversity of points here. We like to get a nice diversity of points in intercept. So that way we can have a good idea of what this graph is doing, okay? So I like for us to do 5 points. Okay? Like we practice on the notes and the homework. Plugging in 5 different times. Now I like to do -2, -1, 0, 1, and 2. Those are my ones I choose by default because we get both positive and negative, so we get an idea of what it's doing on the left side of the axis and the right side of the axis. Okay, everybody attention up here, attention up here, attention up here. Thank you. Okay, we have an idea of what it's doing on both sides of the axis. as well as at 0. Also, that way we're not choosing numbers like -10, -15, or +7 or something like that. Those are just kind of random numbers. But these are smaller numbers, so they're usually easier to work with, okay? So what we're going to do is we're going to plug these in to our x and find out what y equals. So when x is -2, we'll find out what y equals. So we'll take y equals 3x plus 1 and make it y equals 3 times -2 plus 1. And we'll figure out what does y equal. So 3 times -2 is -6, and -6 is 5. Or -6 plus 1 is -5. So when x is -2, what's the y equal to? -5. And then we fill out the rest of the table like that. So we're going to take -1 and plug it in the same way. So we say y equals 3 times -1 plus 1. So 3 times -1 is -3. So y will equal -2. Kenny?
Okay, so how many do we need? Like, how many variables do we need to plug in
We're going to plug in 5.
on all of them?
Yep. It gives us a great idea of where we're going, what we're doing, and that way, if a couple of them might not always go on the graph because the numbers might be really big or something like that, so that way, even if a couple go off, we still have plenty. And also, it helps us catch a mistake if we make one. So yeah, we get in the habit of just doing 5. And like I said, I like to choose these 5. It's pretty standard. So y equals 3 times what next?
2.
Try again. 0 plus 1. Well, 3 times 0 is 0. So then y equals 1. Okay. I want you guys to go ahead and finish the last 2 x's. Yeah, after you get the last 2 y's, I want you to plot those points. And after you plot the points, we'll just kind of wait patiently. Justin, what did you end up getting for y when x was 1? You got 4? I agree. Okay. Ryan, what did you end up getting for y when x was 2? I agree. Okay. So then we plot these points. -2, comma, -5. -1, comma, -2. 0, comma, 1. And 1, comma, 4. And 2, comma, 7. Now, if we plot these correctly, what do we notice? These kind of form a straight line, okay? These form a straight line, okay? Hey, can I get a volunteer to pass out rulers? Okay, so you want to pass out rulers? Okay.
Mine doesn't look like that.
Okay. So what does yours look like?
Not bad.
Mine are like,
I think you did too. Oh, you did?
no.
You mixed up the line.
Oh, I did. Never mind.
So what we can use, guys, is we can use these rulers as a straight edge. Okay? It's not like we're actually going to measure something with the ruler. This ruler is a tool that we're just using as a straight edge. So we're just going to use this to assist us in making a straight line. We're going to use this to assist us in making a straight line.
Wait, this is not a ruler. What is this?
It's a straight edge. Sure. Okay. So the way we use this, guys, I want everyone to pay attention up here in case you don't know. You might know, but in case you don't, you line it up. I like to put my pencil at one point, then line up on another point. And ideally, guys, it lines up every single point we're doing right now. And then you draw through it, and I go back up the other way. So I'm going to draw past my original point. So my first and last points were here, and I drew even past that. Okay? We use a straight edge, we line up, and we graph this line. Now, could we have plugged in numbers larger than 2?
Yeah.
Yeah, so we need to go further than what we actually just plotted. So we need to go further up and to the right. Could we go numbers less than -2?
No.
Yeah, we could. We need to go further and negative left and down left, which is why we keep the line going. Now, is there a certain cap, like you can't get above a certain number?
No.
No. Is there a certain cap where it can't get below a certain number?
No.
No, so we need to draw arrows to signify that this keeps going in that direction.
When
It
we want
keeps
it?
going in that direction, so we draw arrows on our lines to say, hey, this continues to go in that direction.
When we want it?
What do you say?
When would we want it?
Want what?
Draw arrows.
You want to draw arrows every single time we have one of these functions. When are you saying when we wouldn't?
Yeah.
If you're just plotting certain points. Otherwise, there are very few times that would be until like recalc. Yes. Ron? Yeah, sure. Go and grab the one over there.
Sorry, one.
Yeah. They're right by that entrance. Okay.
Just got the middle one.
Yes, I did.
Oh, nice. No, hit people with it. Okay. Questions on this, guys?
Hit me.
Okay. Hey, I want you guys. Let's turn our attention to number 2 here. Okay. Or actually, excuse me. If we had gotten one of our points off, would it have been pretty obvious?
Yeah.
Yeah, because it wouldn't have lined up, would it? And that's why we do 5 points, because that way, if we get one off, it's so obvious to us. Whereas if we only do like 2 or 3, sometimes it's not very obvious, okay? We like doing 5 because it's so obvious. It's like, oh, well, that's egregious. It just means like, it's just terribly obvious, okay? Okay. We just like to get in a good habit of doing 5, okay?
5 was our prime.
Me, Mr. Kossel, okay? I like prime numbers, okay? Okay. So I want you guys to try number 2 here, please. Thank you. With the same time. Yes.
Thank you, Lex.
Thank you, Lexi. Steph, I'll actually just hold on. Okay. So I want you guys to try number 2 on your own, please. Thank you.
No one else call him Lex, please. Just me.
Okay.
It's their family thing.
Do your math. Wet. Kenny.
No, I saw you through this up.
I'm confused.
I confused Mr. Kossel. We'll still plug in the same 5 numbers for x, guys. We'll still plug in the same 5 numbers, okay? So that was when you plug in a -2.
Would that be different years?
But we go in order of the x-axis. We still write -2 because we still plug in -2. Oh.
What's a negative?
Oh, we're
supposed to have?
You can't have negative.
Yeah, sorry. I didn't.
Yes, you can.
When you're done or have questions, raise your hand. Don't take anything away.
Oh, I can wrap it. William Christian. Bobby got mom.
Why?
I don't know.
Did you purpose- Do you make up these lessons?
I bet he doesn't, so negative 2. That's a 2 plus 5. Yeah, see it. Thank you.
Oh, heck.
Yeah, your language.
Sorry, guys, stop.
What is oatmeal?
Is this supposed to look like this?
Yes. I have the same one where it says doesn't
I think that's when you talk.
I'm not afraid to admit it. You're afraid to admit it.
Are you afraid to be quiet?
No.
Or Okay, so as I looked around, it looked pretty good, okay? X, comma, Y, overall looks pretty good. So we want to plug in -2, -1, 0, 1, and 2 still, okay? You have to be careful with our negatives. Negative of -2 plus 5. Well, I was concerned with negative. How do we do that? But it's already negative, okay? So we just plug it in still, though. We keep the negative out there, and we just replace the x with a -2. And now once we have that written out, a negative of a negative is a plus 2 plus 3, not to forget. A negative of a negative is a positive 2 plus 5, which is 7. And then what did you get for -1, Nate?
-1, I got 6.
Okay, Kenny, what did you get for 0?
5.
Okay. Lisa, what did you get for 1? Okay. And then Kelly, what did you get for 2? 3. Okay, so we graph these points. -2, comma 7. 1, 2, 3, 4, 5, 6, 7. 1 comma, or -1 comma 6, 0 comma 5, 1 comma 4, and 2 comma 3.
Once you do the first one, it's really
What was that?
once you do the first one, it's kind of
Yeah, once you do the first one, it's a lot easier to plot them because it's just going down by 1 each time. It's kind of like it's a nice little staircase.
So, oh my
And then we plot these points, we graph our line, and hey, it does line up with everything. We go a little past on both sides, and we're all good. Questions on that one, guys? Okay. So we're gonna do right now. Okay, we're gonna do right now.
Oh, that's right.
Is I'm actually going to have you guys do we're gonna skip over 3 for the moment, but do not cross it out. We're gonna skip over 3 for a moment, we're coming back to it. Okay? I wanted to talk about how we would do a problem like number 4. Number 4, we notice that we have a fraction, don't we? We have 3/4 times x. And here's the thing, with 3/4 times x, whenever we have fractions, we want to be careful with what numbers we choose. We want to be extra careful with what x's we choose to plug in. Because if we choose to plug in our normal -2, -1, 0, 1, and 2, that's going to give us some other fractions out. If I experiment with that real quick and I show you guys, don't write this down, but let's say I plug in -2 to start with. Well, that's going to divide out, and we end up getting y is equal to -3/2 plus 1, and that's going to end up being y is equal to -1/2. Well, halves and fractions aren't very fun to graph. We can do it, they aren't very fun. Now, we can really pick whatever numbers we want to plug in, and that's okay. So, I suggest, let's pick numbers that are going to make our life easier. That's why we had -2, -1, 0, 1, and 2 originally, because it made our life easier. But sometimes it won't make our life easier, okay? Sometimes it won't make our life easier. So, does anyone have an idea of what kind of numbers we might want to pick here? Seth?
-3/4.
I don't think -3/4 would be great either, because then we'd end up getting a fraction still, okay? We want to try and get rid of the fraction, okay?
0.
Kelly, what are you thinking? Not quite. We're still thinking fractions right now. What number is going to help us get rid of this fraction, Reese?
0.
0 could, okay? 0 is always a good option, okay? I'm going to put that in our middle option because we always want positive and negatives, okay? So 0 is a good option.
1.
3/4, 0 plus 1, well, 0 times anything, so y is equal to 1. If we plug in 1, 1 times 3/4 is still 3/4. That won't quite work. Kelly, what are you thinking?
Oh, never mind.
Okay?
4.
4! Okay, what's going to happen if we plug in 4? Y is equal to 3/4 times 4 plus 1. Well, that's a 4 over 1. What happens with these 4s?
Cancel each other
They're
out.
not cancel, they
They're cross reduced.
cross reduce.
Out.
And they both become 1. So then we're left with y equals 3 plus 1, because 3 times 1 is 3, over 1 is 1, or 3. So did we get a fraction this time?
No.
No. Why did that happen with 4?
Because
Because 3/4, okay? We matched up with the denominator, and that made our life a little easier, okay?
-4.
So if we tried 4 and it worked, let's try -4. So let's try y equals 3/4 times -4 plus 1. Make that over 1. What's going to happen with these 4 and -4? They're going to cross reduce. The 4 becomes a 1, then -4 becomes a -1. So y is equal to -3 plus 1. Because 3 times -1 is -3. And so y equals what number?
-2.
-2. So we're not dealing with fractions. Okay? And we like not dealing with fractions, okay? So this is 3 numbers. We want another negative and we want another positive. Justin? -8 and 8. Why are you thinking 8? 8's a multiple of 4. And that's the big point I want to drive home on this one, guys. Is right there what Justin said, okay? Is that we want to pick, and I encourage you to write this in, we want to pick multiples of 4. Why are we trying multiples of 4? Why not multiples of 2? Why not multiples of 7? Seth?
Because they will end up as fractions.
Because they will end up as fractions, because what is our denominator?
4.
4, okay? So we want to do multiples. We want to do multiples, excuse me, of whatever the denominator is. That's what's going to make our denominator go away. So we want to do multiples of whatever our denominator is. So if we plug in -8 and 8, we're going to get whole numbers out. And we love whole numbers. They're a lot easier to work with, okay? Not that we can't do fractions, but it's just not as convenient. And at the end of the day, if we get to pick the numbers, why not make it convenient for us? Why not analyze what's happening here and figure out a better way to attack?
Yes.
Okay? So y is equal to 3/4 times -8 plus 1.
I'm down.
Well, -1 or -8 is -8 over 1. I know this planet, Mr. Possum, it's me. Okay? This 4 and a -8, they can cross reduce. 4 becomes a 1, -8 becomes what? -2. So what's 3 times -2? -6 plus 1. So y is what? -5. Okay. So then we can have our last one. Y equals 3/4 times 8. Plus 1. You got 8/1. Cross reduce. So y is equal to 6 plus 1. And what does y end up equaling, Lucas? 7. Yeah, because 4 and 8, 4 becomes 1, 8 becomes 2. What's 3 times 2? Good question. Chris?
Can you find a way to break your system?
No.
What is it?
Okay. So, we'll we'll plot these points. 1, 2, 3, 4, 5, 6, 7, 8. And go down by 5. 1, 2, 3, 4, 5. Then we'll do the next one, and you get a 4, -2. 1, 2, 3, 4. 1, 2. And a 0, 1. That one's easier to graph. 4, 4. And 8, 7. And as we notice, as we start to take their straight edge, they should line up perfectly. Now we probably did some wrong graphing. We'll plug them in. We might not know. We have to figure it out. Questions on that one? So what was the big idea? What was the big idea I wanted you to take away from this problem? Multiples of the dollar. When we have a fraction multiplying with our x, let's make our life easier by picking multiples of our denominator. We still want to do some negative, some positive. 0 is almost always a great choice. Especially 0 is always a great choice. Not almost always. 0 is always a great choice. We want a couple of numbers negative, a couple of numbers positive. Now, we want to pick like -16 though. That's multiple 4, but we want to pick that. No, I guess it gets really big. So we still like prefer -4 and -8 because they're smaller numbers that work out easier. Okay? So what I'm going to ask you guys to do is I'm going to ask you guys to do number 5 on your own. Okay? Do number 5 on your own. You guys just do number 5 on your own. Just number 5 on your own, okay? And when you're done with number 5, okay, you can get it checked by Mrs. Haswell or myself, and then you can get the homework. So when you're done with number 5,
We're not doing number 6?
don't cross number 3 out, okay? But when you're done with number 5, you can ask you can have it checked by Mrs. Haswell or myself, and when you have it checked and have it correct, you can come back and get the homework and we'll begin on that.